He came here, can you hear me? Yes. He came here in 1970 after getting his PhD at the University of Washington, spending some time as a postdoc at Princeton, and then as a research faculty member at Yale. But the way I remember it, Jerry was the last experimental nuclear physicist that used the cyclotron. So he unfortunately had to deal with taking the magnets apart and shipping them to Los Alamos in the end when that all came apart. But Jerry has done a lot here. Besides going through all the ranks, he was Vice Chancellor for Research for several years, I think maybe 10 years. He served as a Jefferson Fellow in Washington, advising on Homeland Security. For people in physics, he was instrumental in getting prep here in physics. We asked for the program to come here. This is the program for research experience with NIST. And Jerry helped. He was in the administration then and advised us on what to do. So without further ado, I am going to turn it over to Jerry. The talk is on the mathematics of, what was it? Mathematics of nuclear proliferation?
Right.
Okay. As opposed to what's up there. So Jerry.
Thank you. It's the time of year for 2025 Jefferson applications. So I hope that you will all, most of you, try to get one of those appointments. I had a fine time. I was working with economists who know mathematics, and so policies are based on assumptions. These assumptions have a logical structure, and we mostly know mathematics is logical. The mathematics can be simple if the assumptions are very general. We will start with nuclear proliferation. Nuclear deterrence, our basis of understanding of deterrence is based upon missile silos, which include those in northeastern Colorado. The something wing is based in Cheyenne, Wyoming. So the policy is the nuclear doctrine that an enemy will be deterred from using nuclear weapons as long as he can be destroyed as a consequence. And as long as nuclear weapons are around, even in small quantities, deterrence is the safest doctrine to deal with. But as we will see, this doctrine will result in an increasing number of nuclear states. My slide did not come out well, and so I define deterrence as prevents an adversary from taking unwanted actions, such as an armed attack. This is the Los Alamos definition of deterrence. Now, mathematics is logical. So a mathematical statement has a simple differential equation, and that statement has solutions, which can be compared to facts or even used to make predictions. If the facts are inconsistent with the mathematical solutions, the stated policy has in fact not been the definition. When a state without nuclear weapons is faced by N of T, number of nuclear armed states, that state will feel it necessary to have their own nuclear weapons to deter possible attack by each of them equally. Even Sweden and Switzerland felt threatened enough to, in the 1960s, to begin nuclear weapons programs to defend their neutrality. Let's not forget that we have fought 2 wars against our possibly closest ally, Great Britain. So the equation is dN dt is proportional to N of T. More states to be deterred give rise to more threats, requiring nuclear deterrence. So A is positive. A depends upon the vulnerability of the state in question, threatened by N of T. And you all know the answer to this. N of T is N0, the number of nuclear states at time equals 0, taken to be 1945, e to the AT. An exponential law gives rise to a doubling time. The doubling time is the logarithm of 2 times A. In 1965, Gordon Moore noticed that the number of transistors on a chip, had a doubling time of about 2 years. This exponential growth, the doubling time implies that, has continued, driven by market forces, by technological advances, and by massive investments. Here's the graph. In 2015, the number of transistors in your cell phone passed 1 billion. Now, these are not transistors as amplifiers. These are transistors are switches, on or off, a binary system. So in September 1949, N of T became 2. The first nuclear detonation of the Soviet Union's bomb. This was at Semipalatinsk, now in Kazakhstan. So N of T became 2, which suffices to find the second derivative, A, second parameter, by way of a doubling time. So the doubling time increased by 4 years. This was in Kazakhstan at the Semipalatinsk test site. I have a copy of this map in my office. The pink fallout patterns are the paths of north winds giving fallout. I was at Kurchatov on the Ili River. uh, about there.
I just want to see if this works. Let's see.
Yes.
Yeah. No, I don't have.
I was in Kurchatov, named after the father of the Soviet nuclear weapon, and Kurchatov is about there. This is a map in Kazakh and Russian. Kazakh has 4 more sounds requiring 4 new letters of the alphabet in the Cyrillic system. So from Kurchatov, we drove down into the test site. No fence, would be a large fence. And I had a car and a driver, a guide, and a translator, and a very pretty Kazakh graduate student.
Jerry, when were you there? When?
I forgot to invite questions, but that's a fair question. A few years ago.
Not in 1940.
Not in 1949. But I took a picture of the Soviet test site. We called it Joe 1. Joseph Stalin was the dictator of Soviet Union at the time. So I can't say I stood at ground zero because it's marshy. It made a dent in the ground. And the most grisly aspect of the museum is glass jars of fetuses aborted because of the fallout. Around the test site were quantities of military equipment and civilian equipment, buses, trucks, tanks. They even built an underground fallout shelter as a metro station. There's no metro anywhere near this. So we were in booties, and we're cautioned not to pick up any souvenirs. So in 1949, the number of nuclear states doubled. The doubling time of 4 years, which corresponds to some A. After 40 years in 1985, and the deterrence equation would lead to an expectation of 2 to the 10th. That's 1,024 nuclear states in 1985. That's more than the number of states in the United Nations. Ergo, the deterrence logic, as expressed in the different deterrence equation, has not been followed in the proliferation arena. Worse yet, the number of binary collisions between states would be equal to n minus 1 times n divided by 2, with a doubling time of which approaches 2 years, just like Moore's law. Your cell phone has more than 1 billion transistors. Fortunately, the coefficient between in this equation is 0, and we've never had nuclear war, meaning it's unthinkable. This is the cartoon I picked up from the Colorado Daily. It shows the nuclear club with a service not responsible to serve anyone. And an Iranian mullah is walking past, reading the sign. Instead, nuclear states, nuclear club, in order to remain exclusive, acts to remain exclusive by embargoes, the nuclear umbrella. I think we have one with Japan. If Japan is attacked by nuclear weapons, we will reply against the offender. And the solution to this equation is a square root, 2ct plus n0 squared, with n0 expected to be 1, the number of nuclear states at t equals 0, 1945. So here's the data table. I challenge you to list these 9 states: USA, USSR, United Kingdom, France, People's Republic of China, and Israel. Israel is a funny thing because they never tested, with one possible exception. And they never tested the nuclear weapons that they had at the time. The CIA said they had 3 nuclear bombs. India, Pakistan, and the North Korea, Democratic People's Republic of Korea. Except there might have been a case. The U.S. had a series of satellites to sense nuclear weapons in the atmosphere. One of these saw a flash in the Southern Ocean off South Africa. The official story was that this was a sunlight reflection with a proper double flash. Double flash results because the nuclear explosion tears off all the electrons in the atom, and it takes a moment, to get back the electrons. A recent reanalysis, and I brought the reference, by De Geer and Wright in Science and Technology Policy, Security Policy, Volume 25, Volume 3, I'm not sure what's going on there, suggests that it was a small nuclear explosion using sound waves recorded in Australian thyroid glands from sheep. Thyroid is your organ in your throat that requires, it's the only requirement is iodine. And iodine 131 is a common fission fragment and has a half-life of about 10 days. This is perhaps a South African Israeli collaboration. The nuclear weapons that Israel had were city busters. They were unsuited to battlefield use. And this might have been a collaboration between the nuclear outsiders. South Africa had 3 nuclear weapons, 6 nuclear weapons, and material for the 7th. And they downblended it to provide power for the reactors. If this is true, then it reverses India and Israel as the demonstration cases. And not shown, not fit, shown by X's are the data. So the data is even better fit by the data. If the Vela event was true. I was teaching international affairs. So that point was not visible. That was North Korea, that event. North Korea test was a fizzle. That's a fission that fizzled. And I was teaching international affairs at the time of that event. And I asked my class, it was a seminar class, to predict how long it would take Japan to build a nuclear weapon. None of the estimates ranged above 2 years. But I suspect there's an office in the basement somewhere that leads the designs of nuclear weapons. Japan has plenty of plutonium and lots of engineering talent. So North Korea, that point, right on time. The class asked me my estimate. I said that the US would promise the sun, the moon, and the stars to Japan not to develop a nuclear weapon. And perhaps that's the origin of the nuclear umbrella. It's perhaps easier to make a fit to the number of nuclear states squared, given the square root dependence. So this is a fit given by N0, essentially 1, and C as stated. A plus B, N0 plus BX, CX. Well, when does N of T become 10? 9 nuclear states solving the equation for 10. T equals 74.5 years, plus or minus 0.3 years, because the tests were done in the northern hemisphere summer. In other words, 2019, 2020 is the estimate for Iran to have nuclear weapons. Meaning, the classic nuclear policy, if followed, would have led to vast proliferation of nuclear weapon states, creating a separate problem. In fact, the data for demonstrations of nuclear weapons agree with a different assumption. The nuclear club has been very effective in restricting its membership by embargoes, nuclear umbrellas, and so forth. Thus, the club should continue its practices. This gives me an excuse to show the cartoon again. We reserve the right to refuse service to anyone. How about the nuclear arms race that followed the deterrence equation? If a nuclear state B has more bombs, then state A may decide to build more bombs in proportion to the anticipated number of B states' nuclear weapons. Notice there are two equations, two variables, N sub A and N sub B. And A depends upon the intelligence services and others. Then state B, to maintain its lead, and I'm not sure I have distinguished between state A and state B, does the same in proportion to the weapons of state A. So depending upon B, the number of nuclear weapons built by B is B times NA. These two could be combined as derivatives. The second derivative of the equation for N sub A and N sub B are separate. So the rates of growth are the same because, after all, AB equals BA. The solutions to this equation, second order differential equation, are that they involve hyperbolic cosines or hyperbolic sines, the sinh or the cosh. And the rates of growth of both states are proportional to the square root of AB or BA. And perhaps there's a time interval. Note the parallel growth. A reminder, singes and coshes are unfamiliar functions. And so I remind you that the sinh starts out at x equals 0 at 0, and the cosh at 1. So I will, both functions tend towards exponentials at large x. I will pick the cosh version because there was one nuclear state in 1945. So we have N0, N sub A equals, how many weapons did it have at t equals 0, the cosh, and N sub B I'm not sure that I kept A and B completely consistent, with perhaps a time lag. With 4 parameters, N sub A, 0, N sub B, 0, and AB and T equals 0, T equals 0, subscript 0, can we reproduce an actual arms race that follows from the initial assumptions? Note that the product of A and B is what determines the solution. Here are the absurd numbers. US plus USSR, or Russia, had 70,000 warheads. That's an absurd number. Our Rocky Flat plants were the source of the machine shop for plutonium. Now it's a wildlife refuge. So I see exponential growth, steeper and steeper, for both states, but perhaps not equal. This is perhaps due to the Soviet Union's, or Russia, lack of industrial capacity. So both A and B, states A and B, had exponential growth in their nuclear inventory. And perhaps treaties took place at this time. The U.S. had already decreased its number of nuclear weapons. Treaties are diplomatic solutions to a problem. There's only one conclusion. There's only one deterrent: widespread fear of nuclear war. I'm surprised that I didn't have any questions, except Michael's. Yes? From intelligence and estimates of how many weapons they could make, the other state could make. So if there were industrial limitations, Russia would be, USSR, Soviet Union, would be at a disadvantage. And this depends upon the rate of plutonium production. We had reactors at Hanford, Washington, and in South Carolina that made lots of plutonium. And Rocky Flats was the machine shop for plutonium. Yes?
Very surprised us with this conclusion. So first of all, I'd like to give a round of applause. And now I'd like to open it up for questions. So let's say Tobin. Tobin, Andrew, and David here.
Thanks, Jerry, for the talk. The mathematical sort of underpinnings or premise here is, that states are the holders of nuclear material, nuclear bombs, and there's a low number of them. I'm wondering if you have anything to say about sort of the evolution of nuclear proliferation, which might go to smaller groups that might have dirty bombs or might use nuclear materials in a different way.
A dirty bomb is a means of spreading radioactive material that has to be cleaned up. And a dirty bomb kills nobody. So that's still a threat. But a dirty bomb doesn't kill anybody except in the explosion itself.
So you would just call it outside of this?
I would call it outside. And nuclear deterrence is state to state, diplomatically negotiated.
Thanks very much, Jerry. This is Andrew. Yeah. Are you optimistic about the future, or are we destined to failure in the nuclear enterprise?
That depends, because I'm a nuclear physicist, and I worked in fission. And fission is the means to breed plutonium. And I can't say I'm optimistic, because North Korea is a loose cannon. And if they attacked South Korea with nuclear weapons, we would have no choice but to reply.
Your conclusion about fear begs the question about nuclear power. To what extent can one model the successes and failures of countries to adopt nuclear power as related to nuclear proliferation?
Nuclear power has nothing to do with nuclear proliferation, except the reactors. Reactors, when they change the fuel elements every couple of years, are burning plutonium. And plutonium is the raw material for nuclear physics, nuclear deterrence.
Jerry? Yeah. You replaced the exponential growth equation by this 1 over n growth from kind of exclusion from the club, nuclear club. So do you have some hand-wavy argument for that 1 over n?
The 1 over n arose from graphing the data.
So it's a fit to the data.
The data suggested a square root,
I see.
inverse square root. And that solution occurs naturally in the logic is
Yeah, no, I understand. You got it from the data.
I got it from the data.
And if I may, another question, follow up. It sounded from your abstract that you had an alternative proposal rather than for the deterrent.
The nuclear club has evolved exclusivity arguments, deterrence, embargoes, and so forth. And they should keep it up.
Jerry, so Iran attempted to become number 10, but they've been so far prevented or disinclined. Who do you think number 10 will be?
Iran.
Iran. So they're just going to come back.
Well, the fact that Iran is deeply involved in Palestinian issues and their advanced nature, they are breeding plutonium. When you breed reactor-grade plutonium, you're over halfway towards bomb material.
So you don't think economic sanctions will stop them indefinitely?
No.
No. Okay. I was wondering about your opinion of Ukraine. They've got nuclear power plants, so they probably have plutonium, and they are certainly motivated.
There's no nuclear program to develop nuclear weapons in Ukraine that I know of. There could possibly be an office in the basement working on that.
Are there any other questions?
Well, I do have a second one. Oh, but
Well, go ahead, Mike.
so, Jerry, do you have any data like this US-USSR arms race? Do you have similar data for India versus Pakistan?
India versus Pakistan. That's an interesting case because we published a paper together with atmospheric scientists on a war between India and Pakistan that resulted in them burning one another's cities. Cities burned dirty. And the global famine that would follow such an exchange is unlikely to survive. And we published this in a Pakistani journal to warn the states.
For the intuitive analysis of the situation for the last almost 100 years, I guess. My question is, in this sort of analysis, it seems like the main assumption is if left to their own devices and without any allegiances, everyone will develop the technology required to have nuclear weapons. But what is the role of nuclear information, the science that was sort of top secrets for a long time? What is the role of that in this analysis?
The classification of top secret was inevitable at the beginning. The Japanese Hiroshima and Nagasaki bombs were products of American industry. And they were necessary to catch the attention of the emperor himself, Hirohito. That seems to have done the job. Nuclear power and nuclear weapons are disconnected. There are many states with nuclear power. Not all of them have developed nuclear weapons.
But Gary, I think the question was, are there any nuclear bombs secret? or is everyone know how to do it? They have the willpower.
The secret of nuclear bombs is not E equals mc squared, but they work. They work far too well. And we tested that in New Mexico in 1945 and made the work. So the secret is out. They work. The question is, how do they work? And what's the material?
I don't know if it works. Okay. I was wondering what made you want to look into the proliferation of nuclear weapons in the first place, and going into the conclusion about fear as the main deterrent.
So what am I doing here?
Sorry. How would you suggest spreading fear? Like, do you think people should be more informed
People should be more informed
or less informed?
and not confused between nuclear power, which is a good thing, and nuclear weapons, which are bad things. And this arose because I'm a nuclear physicist, having worked in fission. And I'm a member of the American Nuclear Society, have been for many years. This is the organization that runs nuclear power plants. I'm a member of the non-proliferation group, and this arose some time ago because I gave the differential equation for the doubling time at a non-proliferation session of the American Nuclear Society. So the origin of my concern is basically I'm a nuclear physicist.
Still have time for one more question. Here we go.
Hi. So I have a question about the original Vila incident. So I know originally that the incident was declared not a nuclear detonation because the second pulse of the double light pulse was like uncharacteristic with that of the characteristic double light pulse, or it differed from that slightly. But a lot of those models were based off of like atmospheric testing specifically for like airdrops and surface shots. And this was detonated over the Pacific. So I was wondering if there's been like a reanalysis using things with like higher mass to yield ratios, or including things like water entrainment, and like what the results of that would be.
You are referring to my other seminar about
Okay.
nuclear weapons for non-majors.
Okay, thank you.
Okay, I think we should thank Jerry once again for interesting colloquium. Thank you all for coming. Jerry, the picture that you show with all the weapons by year, is that production?
Demonstration.
Demonstration.
Demonstration of testing